Okay, so the first section of material is this section 1.01, which you can navigate to or follow on the screen here. Try and make that a wee bit bigger. Okay, so for every language, of course, the first thing one has to consider is the Hello World program, and this is the picture in Fortran. Okay, so Fortran program is made up of statements which occur on lines, and line breaks are significant in Fortran. So there's no colons or anything like you have in C or Java to indicate the end of the line. And what we see here is a program which is introduced by this program statement and finished by the end program statement, which is there. And this program has a name, which in this case is example 1. So this program, the source file for this program is in this directory in the repository. So as we go along, you are fully encouraged to try and compile the examples and see what happens. Some of the examples will work, and some of the examples have deliberate errors, which we'll try and sort out as we go along. So the other thing to note about this is that there is a comment here. This is a meaningful comment. Comments are introduced by an exclamation mark in Fortran. You just have to have an exclamation mark at the start, and that's a comment. You can have comments which trail statements at the end of the line, if you so wish. So there's one executable statement in this program. This is this print star hello world in quotation marks, which will output to the standard output string hello world, and standard output should be the screen for everybody in our case. Okay, so if you haven't done so already, please make sure you can compile and run that program. So throughout these I won't call them slides, I'll call them material. I have various exercises. Against each exercise is an amount of time. Please don't take this amount of time too seriously. It's really more for me to make a rough guide of how long to leave people to have a go at these things. So I reckon this should take about a minute, but please don't feel it's a race. If anybody is still having a problem with getting this going, please do type a message into the chat, or raise your hand, or let us know somehow. And we'll try and sort it out. So if I go to, I'll go to my copy of the repository. Here, if you're on ARCHER2, it's FDN for the Fortran compiler. This example is example 1, .f90. So you'll see by convention the extension for Fortran 90 files is .f90, which reflects this Fortran 90 standard I was talking about, but that does not preclude or does not mandate that you must stick to Fortran 90 in that file. I mean, you can just any old Fortran after the 1990 standard should be okay. So that should give us a default executable, which is this a.out. You can run this executable like so, and hopefully that should give us hello world. Okay, so that, they claim, is probably the most difficult program you will write in any language, so hopefully everybody can manage that. How are we doing? Anybody got any troubles? Yeah, somebody who's in the chat is asking about write. I'll come on to that just later on. So as again, I will try and emphasize there's, for any given thing you want to do, there may be more than one way to do it in Fortran. There are alternatives to getting output, which we'll see as we go along. So again, so the main points are we've got a program. So this is roughly analogous to what is you would have as a main in C or C++. Or your main in Python world, which is what will get executed when you run the program. So here is a formal description of that. I don't want to get too carried away with formal descriptions in this course, but they do have their uses. So for the formal descriptions, anything appearing in these square brackets is formally optional, and anything which is not in square brackets is mandatory, so you must have it. So for the program, the formal situation is this. Formally, you can start a program. There is something called a specification part and an executable part. I'll come back to this contains thing when we get to talk about modules, but I don't want to worry about that now. You'll see from this formal description, the only mandatory element is actually the end statement. It actually means that the shortest possible standard conforming Fortran program is this one here. Not a terribly interesting program, but possibly the answer to a trivia question. Note, if you do have this optional program name, it needs to be the same, obviously, in both places, or the compiler will get confused. So example 1 there must match example 1 there. Okay, so the other thing we saw in that first program was a print statement. So this is a simple way to get output to the standard output, which is usually the screen. So formally, you print. There is then something called a format specifier, which will be a string, or it can also be an asterisk, a star, which we saw. And then you just have a comma separated list of items you want to output. The star is often called free format, or sometimes list directed format, and that's just basically saying please do the best job you can with what I've given you. So people with eagle eyes may have noticed that when we ran our Hello World program, down here we got this string here, which has a space at the start. If you look at the program, that string does not have a space at the start. So that's coming from the free format, basically, and that may be slightly different depending on which implementation you have. Okay, so that's print. So as I was saying, there's usually more than one way to skin the cat in Fortran, and this next example program gives us a slightly different way of doing it. So I've introduced a couple of new things here. We've still got our program. This one's called example 3. Again, this example is in the repository, so you can have a look at it if you like. So instead of print, I'm going to use this write statement, which is a slightly more complex version of print, if you like, which is a statement in Fortran. It takes a series of arguments which appear in the parentheses here. It so happens there are a great many arguments, possible arguments to write, which we'll look at more closely when we get to dealing with external files. So again, I've just got my list of things, comma separated list of things I want to write. Hello world. I just happened to, you could have one string there. I just happened to have separated it into two. So inside the arguments to the right, we have this thing, output unit, which is going to tell write where to send the output, and we have a star. So this is the same, this is the format, this is the free format, which is doing the same job as the star we saw in the print statement here. Okay, so when we ask where's this thing output unit, this symbol output unit is got to be defined somewhere, and it's coming from a module, so-called, in Fortran, which is imported, if I can use that word with caution, or used in the Fortran jargon, and this module is called ISO Fortran Env. So this is a special module known as an intrinsic module, which must be provided by the implementation. So this thing is always available. And the other thing I've introduced here is this only clause to the use statement, which is telling the compiler the only symbol I want from this module is output unit. If you don't have that, it will include all the symbols from the ISO Fortran Env module. Okay, so that's a slightly different way of using output, and also this ISO Fortran Env module. We'll be using this quite a bit today. So that's the formal statement again. The only list at the end is optional. If you don't include it, you'll get all the symbols available. Some people like to control very closely which symbols they import to try and guard against namespace pollution of unnecessary symbols. So note, there's no, if you're coming from things like C++, there's no formal mechanism in Fortran analogous to the sort of namespace type idea. So here's again the writer sort of slightly more formal statement about write. There is in parentheses here, there is potentially quite a long list of arguments, and then there is the list, comma separated list of the things you actually want to output. The two arguments we're going to see a lot are the what's called a unit number in Fortran, which in this case is this special output unit, and the format. So those are described there. Again, you'll see there's various flavors of how you write this. You can be completely explicit and have something like that, and say unit equals the output unit, and format equals the free format star. Or you can just have an abbreviated version like so, or you may even see this, where the unit number has been replaced by a star, and a star in this context means the default output unit, which again one expects to be the screen. Okay, so that's the sort of basics of getting some output. So hopefully, if you want to examine what's going on in your program, print or write, I don't mind which, but both exist. A few comments on style. One always treads very carefully in computer programming about questions of style. This can kick off all kinds of controversy, but I will say this much for this course. Fortran is not case sensitive, unlike many other languages like C, C++, and so forth. Fortran is not case sensitive, so it doesn't matter whether you have uppercase or lowercase, really. There was a time when actually uppercase was mandatory. If you look around, you may see older programs with a lot of capital letters in them, like so. Particularly, some people may just capitalize the keywords or statements in Fortran and have other things in lowercase. I take the view that as modern computer etiquette tends to regard capitals as shouting, probably best avoided. So I will, in this course, conform to an all lowercase style. So again, if you have things like variable names, they're not case sensitive. I'll come on to variables in the next section. So as a bit of an exercise, maybe I'll have 4 or 5 minutes for this, just to have a bit of a go. So write a program which prints or writes the actual values of these symbols: output unit, error unit, and input unit, which all coming from ISO Fortran env to the screen. So they're actually integers and they have a value, so you can see what the value actually is by just printing them out. So I'll shut up for a couple of minutes and let you have a go at that. If there are any questions, just please let us know in the chat or raise your hand. So there's a couple of questions in the chat. I'll just go over. I think one asking about make files. Yes, you can use make files if you so wish for Fortran. So make will just execute rules. If the rules are appropriate for Fortran, that's fine. There's a question about why is so somebody has obviously run the program and found that the output unit is number 6, the error unit is number 0, and the input unit is number 5. So why is the question? Well, again, in Fortran, there's some history behind it. It just so happens that the screen was units. The 6, they started counting different kinds of device at 1, 2, 3, 4, 5, 6, and so on. And the screen came up as 6. Input unit is 5, is typically the keyboard, which is 5. We'll have another look at that in just a moment. There's another question about colons. So this is double colon and single colon. So this is uh, really just a question of the syntax that has been chosen. Most commonly, you will see the double colon, like so, which indicates that this is the end of an attribute list. You'll see a lot of double colons. The single colon there is really related specifically to that only list, so you don't see the single colon so often. Okay, so hopefully everybody has had a chance to have a go with this exercise that is in this directory. Yeah, that's interesting. Fortran translates into emojis in the chat. Well, you learn something every day. So so as I was saying, so what's the difference between these two? If I interpret this right, here you've just explicitly said I want to use this output unit, which is defined using this symbol. There, where you've got a star, is saying I want the default output unit, which happens to be the same thing. So actually, there is effectively no difference, except how you've introduced the default output unit. I think that's the only difference. So I'm going to have a go at compiling this program. So I'm over here on ARCHER2. I've, for the sake of interest, moved over to the default Cray compiler. So if I do fdn, what's it called, exercise 1.f90, again I should have an executable a.out, and I run this. For Cray Fortran, we actually see that the output unit is 101, the error unit is 102, and the input unit is 100. So there's no particular magic in any of these numbers. They're just numbers the implementation has chosen to define these different units. So you should use the symbolic constants to ensure you have a portable program. So I think there's a bit of an extra question in the somebody may have got to this. If we were to do something like the following, if we were to accidentally miss out the input unit, for example, up there, but still reference it down here, we can ask the question, what happens? So has anybody done something like that and observed the result? Yes, that's because I'm not saying anything. Okay, right, yep. Rakesh has an answer. We get a rather alarming situation where the output unit is suddenly some rather large negative number. So that I'm going to explain. So that obviously doesn't look very good. And I'm going to explain that in the next section. What has happened. So we'll go navigate to the next section, which is section 1.02. Any other questions before we go on? Okay. Okay, so the next thing to do anything useful, we need some variables. And Fortran offers the following selection of intrinsic variable types. These hopefully fairly familiar. So there is integer, so this is whole numbers, so this is like int in C-like languages. There is floating point numbers, which in Fortran are called real. So this is like your float and double in C-like languages. Fortran has an intrinsic complex number type, which is good if you're doing things like quantum mechanics and so on. So those three are numeric data types. There are also two non-numeric types. So there is a logical, which is the sort of analog of Boolean type, true and false, and there is character, which is related to strings. So we'll have a look at the numeric types first. I'll say more about strings, particularly. Won't say more about it until later. So here's a set of variable declarations. I have in my example program here. Again, I've introduced a couple of new things here. So I have a declaration, again followed by this double colon thing, is the syntax for each of integer, real, and complex type. So the variable name and an initial value are provided after the colon here. So I is an integer, A is a real number, and this complex number Z is a compound of two real numbers, which can be initialized like so, with a real part and an imaginary part. The initial value, you don't have to have an initial value, you can just have a declaration of a variable name without initialization, in which case the variable is said to be undefined. Names, again, valid variable names in Fortran are composed either characters A to Z, numbers 0 to 9, or an underscore. And a valid variable name must begin with a character. So, for example, you can't start a variable name with an underscore. Okay, so should you ever wish, you can have variable names of up to 63 characters. Again, I should stress the main thing, if you're coming from a C-like language, the main thing to remember is that, again, Fortran is not case sensitive, so a variable with a capital in C is not the same object as a variable with a lowercase letter. In Fortran it is. So the other thing you'll see I've introduced for the first time here in this program is this implicit non statement. I'll say a bit more about what that is in a moment, and this relates to this strange problem we were seeing with this input unit. Okay, so the situation in Fortran is one in which they have something called implicit typing. So the default situation in Fortran is that any name that's accessed is its data type is interpreted by the first letter of the variable name. So the default situation is that anything beginning with letters I, J, K, L, M, N is an integer, and anything else is a floating point number. Now, obviously, at this point, the programmers amongst you are screaming, surely this is complete madness. And indeed, to some extent, it is. So there is a method to turn off this so-called implicit typing, and this is to use this implicit non. So here, what I'm saying by putting this implicit non here is I'm basically saying is that all variables referenced in the program must be explicitly declared before they are used, or the compiler will give an error. So again, there's a history to this. You would never do this if you were designing a language from scratch today. But that is there and can be safely avoided by using this implicit non. So I'm recommending, well, I'm not, I will put it even stronger, more strongly than that. I am demanding from now on that every program has an implicit non statement in it. So the problem is illustrated by this little exercise here, which you can have a go at now, just before we get to the break. So the question in the chat about the difference between the first line of using the intrinsic module ISO Fortran env. So the first line is just saying, please give me all the symbols that may be defined in this ISO Fortran env module. The second is just saying, please give me only the following symbols. It's not a question of speed. It's really just restricting the names that are available from that module. So usually good practice. So if you're coming from Python, for example, if you do import statements, it's usually considered good practice not to import things, star everything from, but only the things you need to avoid, or sometimes referred to as include what you use in the C community. So you only import the symbols you actually want rather than everything en masse. So it's really, that's the reason. Okay, so just before the break, hopefully everybody has sussed out the issue here. So if I were to compile this example, in which I do the following, one might be surprised to see that the output is not what is expected. So the answer to this, of course, is that there is a typo in this program, and the solution is, oops, that's not the right file, is it? The improvement I am going to demand is if we stick that in and I try and compile again, right, I should now get a message from the compiler which is saying something like implicit none is specified in the local scope, therefore an explicit type must be declared for the variable L1. So that's the problem. That is L1, and the declaration was LL, I think. Okay, just so we'll have a break. So we'll have the scheduled break now. Please feel free to have a go. Yeah, exercise. Incidentally, I should also say that was that is the nature of the problem we saw in the previous exercise, which was this one, where you see there's no implicit none. So if I take out the input unit here, the input unit is no longer being imported from the ISO Fortran env module. It's merely an undefined variable in this case. So there's the danger of not, there's a danger of not having implicit non. So how did I get the compiler to spot the error? So in this case, this is by introducing the implicit none statement. So here, it so happens that the implicit none needs to go after the use statement. So if I do that and try and compile again, exercise 1, because I've specified implicit none, the compiler is now telling me this thing is not defined. And therefore it is an error. Okay, so as I said, we will stick to the break religiously, and we will start again at 11:30 Greenwich Mean Time.